Ooh. So yesterday we learned a little bit about addition and subtraction, and if you remember back to elementary school, once you knew about addition and subtraction, you were just hungry for more. So I'm going to give that to you in the form of multiplication and division. So let's take a look at this fun little example here, which clearly imported in a weird way. Sometimes that happens, children. Sometimes the PowerPoints to my program that I like to use doesn't import that great, but we'll be all right. I'll help you out. Okay, so we got B and C trisect AD. We got F and G trisect EH. What can we conclude about AB and EF are congruent to each other, so what can we conclude about EH and AD? That's what that says. What can you conclude about? Okay, and those segments are supposed to be up there with the and, not like they look like blanks right now. Anywho. Okay, so I've got AB and EF are congruent. What can I conclude about this whole thing and this whole thing? Well, how about I put some values to it? Because, you know, sometimes I like some numbers. Some numbers are nice. So let's say this is 3, which would make this 3, right? Now, if it was trisected, these would all be congruent. So we get 3, 3, and 3. What are these going to equal? 9 and 9. So what do we know about AD and EH? They are congruent. That actually worked out quite well that alignment was off, so I could just toss that between. Woo! They're equal measure, they're congruent. But why? But why? Well, children, if you take this segment and you multiply it by 3, you get 9. If you take this segment, you multiply by 3, you get 9. But we're not always given actual numbers, remember? We're not always given numbers here. Thinking more of like, you know, it could be anything. Right? So, but if I'm multiplying the segment length, then I'm going to get that whole thing. That's called the multiplication property. And if I gave you that the whole thing, AD and EH were congruent, you could then conclude back to AB and EF being congruent by division property. So they work alongside each other and they coexist together. All right, so let's get formal with it. All right, so I'd say this is somewhat formal. Multiplication property. We're going from small to big, kind of like addition was small to big. Division, other way around, big to small. And we did that last example with both. I think with some proofs it become even more clear. The key words that you're looking for are midpoint, bisect, and trisect. And that x2, the times 2, means you're going to hear it or see it twice. Like both of these things are trisected, or both these segments are bisected, or both these angles are trisected. Okay? So you're going to look for it twice. Otherwise, you can't really do it. And you'll see why here with some examples. So let's take a look. I've got MK is congruent to FG. I know that KG bisects FH and MJ. But I want to conclude that these two are congruent. Okay. So if KG bisects FH and MJ, one could also word this as KG bisects FH and KG bisects MJ. So you're seeing bisect twice. So that triggers you to think, ooh, this could be multiplication or division. So from MK to MJ, am I going from small to big or big to small? I'm going from small to big, and same with FG to FH. So we're thinking multiplication property. Okay, here we go. So, actually, I think we're basically ready to rock and roll. Two-step. All right, I got MJ is congruent to FH by multiplication property. If I take two congruent pieces and I multiply them by 2, I'm going to get two congruent pieces, two congruent segments in this case, that are congruent to each other as well. They're just double the size. Bisecting is half, so doubling it, right? You go back the other way. So that would be so it'd be multiplication property. And if I was going the other way, if I gave you MJ is congruent to FH and I asked you to prove that MK is congruent to FG, if I switched this part and this part in my given and prove, that's a totally legit proof to give you. And the actual proof would be pretty much the same, except for your statement for number 2 would be different, but it would still, and then your reason would end up being division, because I'm going from big to small. Okay? So let's try a non-proof, all right? A little not a proof. Take a little break from the proof, and then we'll get back to it. So here it says, given B and C trisect AD, F and D trisect EH, and I know that AD is congruent to EH. If AD equals 12, find EF. Or sorry, and EF equals x minus 8, find x. Okay. So I know that these two are congruent, right? And I know that this is 12. So I've got two big segments that are congruent. I know that EF is x minus 8, and I want to solve for x. So there's a couple ways to actually solve this one. But what I'm really thinking about here is that my multiplication and division properties, because I see trisect twice. Well, any ideas what EF could equal? Well, if AD and EH are congruent, then this is also 12, right? And if it was trisected, that guy would equal 4. So x minus 8 equals 4. X equals 12. It is a coincidence that it is 12, and the overall segment length is 12. X is just 12, allowing EF to be 4. That is so darn cool. Awesome. Alrighty, last problem. A lot in the given here. Again, once in this problem here, just like we had before, but let's see if we can keep it organized. And I'm running out of my lunch period here, so I'm going to try and move a little quickly. All right, we know that NOP is congruent to RPO. Awesome. Are those right angles? I don't know yet. I haven't read the rest of the problem. They look like it. Doesn't matter. We got to be told. All right, it says NSO is comp to SPO. I'm going to do that in green like we did before. NSO. Oops. I'm going to put a C there. And then SOP. And then I've got RTP and TPO. Another little comp action. All right, PT, oh man, PT bisects RPO, which would mean it splits into two congruent parts, right? So we got some bisecting going over at this angle and bisecting going over here at this angle. All right, so if I saw bisect, I'm thinking multiplication or division, right? Alrighty, let's see if we can organize our thoughts and put something together here that is super awesome and cool in order to get NSO congruent to RTP. Well, I see that those two angles have a little complementary relationship going on here, right? So if I can prove that this angle and this angle, those two that are complementary to the upper two, if I can prove they're congruent, I know that comps of congruent angles are congruent. I've got this whole angle congruent to this whole angle, and I've also got some bisecting going on. So with bisecting, I can prove that this angle is congruent to this one by, big to small means division. Let's write it up. All right, I'm going to go back to blue here. Given. All righty, so angle SOP is congruent to angle TPO by division property. Remember, I'm going from big to small. And then I've got, oh, I'm already there. Heck yeah, another one of these crazy problems where there's so much given, but if I just organize my thoughts and jot things down, it's actually not too terrible. At least for me, because I've done this for like 7 years now. All right. So we've got those two angles congruent. How did I get that? Well, if I know that these two are congruent by division property, and I know that these two are complementary to those two congruent angles, I've got comps of congruent angles are congruent. That was a better congruent sign than this one. Okay. That's it. America, awesome, freedom, rock and roll, YOLO, hashtags. Make sure you get some H-dubs in there. Again, these days may change, because I don't record new videos every year, but we will have a quiz coming up. Make sure you check your calendar on the website. I'm not even going to say what the website name is, because who knows? It could change companies at one point,